Okay, so again, stay together, stay with me. Is this going to be everything? No. Most stuff. Now, you still have a chapter review at the end of your book. Feel free to use it. It's helpful. I would work problems out of the chapter review, and I think you have the odd answers to the chapter review as well. So if you work odds in the chapter review, you'll know if you're getting them correct. All right, go ahead and fill in number 1 if you know it. If you know it, fill it in. Write the recursive formula for an arithmetic sequence. You either know it or you don't. If you don't know it, don't write anything, and I'll give it to you in a minute. You either know it or you don't. How many think you know it? Let me see your hands. Okay, so if you know it, you wrote a sub, I'm stuck in green here, let me get out of my green. A sub n minus 1 plus d. That's the recursive formula. How many got it right? Okay, and the rest of you, look, is that something that's impossible to learn? No, you just haven't reviewed it and studied it. That's why you don't know it yet. That is a recursive formula. 1b for the arithmetic sequence. A sub n equals a sub 1 plus n minus 1d. This is the blank formula, right in the blank. What fills that in? Which formula is this? Well, I'll give you a hint. It's not the recursive formula. Therefore, it is the explicit formula. So let me one more time review for you what each does. The recursive formula allows you to find the next term when you know the previous one. Again, n minus 1 is the previous term. Add d to any previous term and you'll get the next term. However, the explicit formula allows you to find any term, and therefore the difference. And so we'll use them. All right, go ahead and do 2a. Yes or no? Is 170,033 divisible by 3? Shouldn't take you long on that. Class, yes or no?
No.
No, because it does not pass the divisibility test. Now, look, even though the 33 is good, you got to add 1 and 7, you get 8. 3 more is 11. 3 more is 14. Is 14 divisible by 3? No, and it's a no. Okay, do we have a divisibility rule for 7? Yes or no?
No.
No, so figure out if that one's divisible by 7, yes or no. To be or not to be? That is the question. Is it divisible by 7, yes or no? So some of you are doing nothing. Does that mean you don't know what to do, or you already decided on the answer? Which is it? Decide it? Yes or no?
Yes.
So half of you are saying yes and half of you are saying no. And anybody that really wants to know is going to divide it and see if that is the case. That's how you're going to tell. Goes in once, goes in once, bring down the 5, 0, bring down the 8. 7 times 7 is 49. 7 times 8 is 56. 2, bring down the 1. 7 goes in and 21. 3 times, no remainder. Answer is yes. Why? Because it divides in evenly. So again, those of you that were sitting there doing nothing, I don't know how you're figuring that out. Maybe you were doing the long division in your head. Is that smart?
No.
To do long division in your head? That's stupid. All right? Don't be stupid. You used the stupid word. Well, if you're going to act stupid, it's being stupid. It has nothing to do with your IQ. It has to do more with laziness, doesn't it? All right? It's lazy. All right. To be lazy is stupid. All right. I should know. I was lazy last night, and it was a stupid thing, and it was dumb, and I paid for it. All right. Go ahead and find the GCF and LCM of those numbers. Go ahead and find the GCF and LCM of those numbers. All right. You should be close to done. Shouldn't take long. I already gave you the chart. GCF, 2 times 3 times 3 times 7. 9 times 7 is?
63.
2 times 63 is? 126. Remember, our GCFs we will give the final answer to. It's usually not a big deal to multiply out GCFs. They're always smaller numbers. LCM. So remember, GCF only where you have a full column, LCM every column, right? So this is going to be a 2 squared times 3 squared times 5 times 7 times 11. You definitely don't want to take the time to multiply that out, right? And most of you guys are good with your LCMs and GCFs. Mason.
For the GCF, wouldn't it be 2 times 3 is 6 times 3 is 18 times 7 is 133?
18 times 7 is 126. And again, the commutative property is a whole lot easier. Doing 7 times 9 and getting 63, and doubling 63 is a whole lot easier because nobody knows their 18 times table. And you just prove that you can get them wrong going that way. Okay. All right. Go ahead and for 5 and 6, the two numbers are the same two numbers. Give me the GCF. Give me the LCM. I'm not going to give you a ton of time on these, but take a couple minutes, see if you can figure those out. So we're also practicing factoring the prime numbers, right? So hopefully you got 2 times 2 times 3 times 5 for the first, and 2 times 2 times 5 times 7 for the second. Now I'm ready for my GCF. Where do I have full columns? 2 and 2 and 5. 4 times 5 is 20. How many got that one correct? Now again, if you factor wrong, you're going to get it wrong. LCM, include every column. By the way, notice how I made a chart. How many of you made a chart? Oh, good. We do have some smart ones among us, right? That's what I was trying to teach you. And 2 squared times 3 times 5 times 7, right? How many got that right? Okay, again, you're pretty good with your LCMs and GCFs. Just be careful when you're factoring. Again, let me remind you, what number do I see students often leave and not factor prime? The number 4. So be careful with those 4s. Make sure you get them to 2 times 2, right? That will affect you, and you don't want to do that. All right, let's take a look at number 7 here. For the sequence, r equals negative 21, negative 16, negative 11, negative 6. Find r sub 7, right? Go ahead and do that one. What is r sub 7? Oh, I wrote that like, got rid of all that. 4 is the 6th, and what is 9 the 7th? Right, do you agree? So again, you thought, okay, I can figure out D, it's a 5. So I'll add 5 to the negative 6, right? The recursive idea, I can get the next one. I get negative 1. Add 5 to the negative 1, I get 4, that's the 6th. Add 5 to the 4, and I get 9. How many got that one right? Okay, good. How about number 8? For the arithmetic sequence, if a sub 1 equals negative 52 and D is 6, write the first 4 terms. See what you can do with that. Write the first 4 terms. Just going to give you a minute on this one. Some of you struggle a little with negative numbers, but if you can do it with negatives, you can do it with positives, right? It looks to me like negative 52, negative 46, negative 40, and negative 34, right, as I add 6 each time. Remember, a sub 1 is the first term. That's the biggest deal there. A sub 1 is the first term, and then I continue on from there. Okay, let's get to the back. The back has more stuff that you got to be careful with. I think you guys are pretty good on most of that stuff on the front. All right, go ahead and do number 9. Some of you missed this type of question on the quiz. Let's see if we can pick it up now. What is a sub 33? What is a sub 33? So again, if you're thinking, you realize the n is a 33. That's the whole deal of the problem. 99 minus 4, we can all do that, right? And hopefully you said 95 is the answer. How many got that one right? Okay. So that's the easier kind because, listen, I gave you the explicit formula, which allows you to find any term. So that made that pretty easy. What happens in number 10, we don't have the explicit formula. I'm going to do this one together for time's sake. Most of you will miss a problem like number 10 because it's the harder one. If you'll write the explicit formula, a sub n equals, can anybody finish it for me? Explicit formula. Michael?
And then a sub 1 plus parentheses n minus 1 parentheses d.
Correct. So it's a sub 1 plus the quantity n minus 1 times d. That's all we need. Now we can finish it. Now let's do 101 for our n. So class, what's a sub 1?
3.
Right? It's the first number, so it's 3. What do we put in for n?
101.
101, then minus 1. Uh-oh, what do we put in for d?
5.
5, right? You can figure out the common difference. There we go. So what do you end up with? I gave you an easy one. 101 minus 1 is, what's 100 times 5?
500.
What's 500 plus 3?
503.
There you go, and away you go, right? But you had to know to start with the explicit formula, right? Because that allows you to find any term. And definitely 101 is any term. Now look, you can sit there and count 101 numbers if you want, but you're going to burn up your time, and then you're going to say, I ran out of time for the test. Yeah, because you didn't know the best way to solve the problem. But wait, if you got a lot of time at the end and you want to count 101 numbers, knock yourself out. But what if that was 1,001? Then you'd be in trouble. All right, let's get to some base work. Write 432 base 5 in base 10. Remember, the whole key is multiplication and multiplying by the multipliers. You try to do it at your desk. I'm going to start doing it up here. So if you want to, if you don't know what to do, watch me. If you know what to do, try to do it at your desk. And this looks like 100 plus 15 plus 2. So it looks to be 117 to me. And I'm not going to write subscript 10 because normal is base 10. Right? We changed from base 5 to base 10. So again, I went right to left. I did 5 to the 0, 5 to the, see my base, right? 5 to the 0, this is the multiplier. 5 to the first, 5 to the second. 5 to the 0 is 1, 5 to the first is 5, 5 squared is 25. I didn't need 5 cubed. I only had 3 things. So then you got to do the number times it, plus the next one times it, plus the next one times it, add it all up. Voila. Okay, so with that in mind, do number 12. 1, 1, 1, 1, 1, 1, 1. Oh, by the way, notice there are no commas. In bases other than 10, you don't write the commas. I know that's weird, but you don't. So just the way it goes. We don't do commas. We do in base 10. We don't in base 2, 5, 12, 17, 34, hike. All right, again, for time's sake, I'm going to be doing this while you're doing it. 1, 2, 3, 4, 5, 6, 7 of them. 1, 2, 3, 4, 5, 6, 7. Right, I always start with my exponents, right to left. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4. Multiply the 4 times 2, get 8. Multiply the 8 times 2, get 16. Multiply the 16 times 2, get 32. Multiply the 32 times 2, get what? Right? Do you realize it's always times the base will give you the next one? So now I got all the ones I need, right? So now it's what? 1 times 64 plus 1 times 32 plus 1 times 16 plus 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. 64 and 32, 96, 106, 112, 120, 127 was that number. Okay, just figured I'd play around with the 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. All right, you guys definitely have a harder time going the other direction. When I say write it in binary, I want you to write it in base what?
2.
2. All right. So remember, you guys have a harder time this way. So I need to list out my 2's. Let's see, do I have enough? Let me write them. This is a 1, this is a 2, this is a 4, this is an 8. No, because the number's 47. 2 to the 4th is a 16. I still don't have enough. 2 to the 5th is a 32. And that will work. I am now ready to take my 32 and divide it into my 47. Remember that?
Yeah.
So it goes in once, and I get 15 remainder. And now I try the next number, which is a 16, into that remainder. Does it go in? No, so that one's a 0. Now I do my 8 into the 15. Goes in once. Got a 7 left. Now I do my 4 into the 7. Goes in once. Got a 3 left. Now I do my 2 into the remainder. Goes in once. I got a 1 left. Now I do my 1 in the remainder, and it's a 1. What number is this? 1, 0, 1, 1, 1, 1. Do I use the subscript?
Yes.
1, 0, 1, 1, 1, 1, subscript 2. And I'm running out of time, but it's hanging there. Let me do these last few. All right, bases bigger than 10. Here's the key to all of this. The number 10 is the letter A, right? Because you can't have 2 digits. The number 11 is a B. 12 is the C. Okay? Because you can't, it's got to be a single thing. So when I have 1C4, it's like a 1, 12, 4. Again, how do I convert? My multipliers are 12 to the 0, 12 to the first, 12 squared, right? You guys might be better off watching instead of doing, because I got to go fast. This is a 1, this is a 12, this is a 144. Agreed? I need it 3 because I have 3 digits, right? So I'll multiply the 144 by what? Say it if you know it. The 144 gets multiplied by what?
1C.
This 1. The 12 gets multiplied by what?
12.
The C value, which is a 12. And the last one on the right gets multiplied by a 4. So what do I get? 144 plus 144 plus 4, 288, 292, right? Those are fun with other letters. Hey, before you pack up, still my time. I've been great getting you out early this year, and it's been early every time. How would you find the LCD of these? What would you do? I just want somebody to explain it. Go ahead, Abigail. How do I find the common denominator? That's what I'm asking. How do I find the lowest common denominator? What's the idea? Elise? Justina?
Break down the common denominator.
What are you trying to find? What are you after? Josias? You want the least common multiple of what? Of the denominators. Find the LCM of those 3 numbers. I could care less what the numerators are. The question is, find the LCM of 12, 18, and 27. That's the question. That's all you got to find, the LCM. All right, my time's up. You are dismissed, lunch. Test on Monday. Be ready.